Hello. Today I'm going to derive the algorithm for backpropagation for a linear layer with a vector input. So this linear layer is going to look like y is equal to wx plus b. And if we expand this out, we get, well, because we've got vector input, y is going to be a vector output also. y0, y1, so on, is equal to, and then w0, 1, so on, w10, w11, so on, and then so, and then x is just a vector input, x0, x1, so on, plus b0, b1, so on. And if we do this matrix multiplication, then we get, let's copy this. Is equal to, so w0 times x0 plus w01 times x1 and so on. And then for the next entry, we're going to get this times this, w10 x0 plus w11 x1 plus dot, and then as you can see, you just go up 1 and then add on the biases. So if we consider what is y I, then it's just the sum over, say, j of, so as you can see, it's this second axis which is incrementing, and also the x is incrementing, so it's w I j x j, and then plus bi. So now we can take the partial derivatives of yi with respect to wij, xj, bi. So the partial derivative of yi with respect to wij is just going to be xj. Partial derivative of yi with respect to xj is just going to be wij. And the partial derivative of yi with respect to bi is just 1. So, given that we have, we will already have calculated the derivative of the loss with respect to each of the y entries. So we'll have d del loss by del y, which is a vector which looks something like this: del L by del y0, del L by del y1, dot. So we're already going to know this vector. So if we find del L by del Wij, then by the chain rule it's just del L by del Y times, well, del L by del Yi times del Yi by del Wij. And this is just del L by del Yi times, and then del Yi by del Wij, we already know, is just xj. So here's the formula for one entry of the matrix del L by del W. So if we write out the whole matrix, del L by del W is equal to, so in this row I is going to be equal to 0, in the next row I is equal to 1, and so on, and in this column j is going to be equal to 0. So if we fill these in, so del L by del Y I, but I is 0, times xj, j is 0, and then the next entry, j is going to be 1, so del L by del Y I, which is 0, times xj, which is 1, and then I think you see the pattern, del L by del Y 0, x2 for j is equal to 2, and so on. And then for the next row, I is equal to 1, so del L by del Y I is going to be y1, and then xj 0, and then del L by del Y 1 x 1, and then del L by del Y 1 x2, and then maybe for this next row I is equal to 2, so I think you see the pattern by now, del L by del Y 2 x 0, del L by del Y 2 x 1 dot dot, del L by del Y 2 x 2. Now then, as you can see, this can be written as del L by del Y 0, del L by del Y 1 times x 0, x 1, and so on. As you can see, it's just this outer product, so this term is this times this term's this times this term, well, this times this. So this is just del L by del Y, and this is x transpose. So in total we have del L by del W is del L by del Y times x transpose. So next we want the partial derivative of L with respect to either the bias or the input x. Let's just go with the input next. So the partial derivative of L with respect, so let's just start off with a single entry first again, by del, let's say xj, is equal to, so y, we've got yi at the top, so del L by del yi times del yi by del xj. So I'm going to explain to you in a second, but because this, well, we need to sum over the i's here, which is basically the multivariate chain rule. So as you can see from here, this x0 starts off just in one dimension. But as you can see, it ends up here and here. So if you don't know about the multivariate chain rule, then I recommend you look at Kahn Academy. I'll link some videos in the description. But as you can see, we're going from a single dimension into many dimensions and then back to one dimension because the loss is just one dimensional. So if we just write out what these are, so sum over I, del L by del yi, and now del yi by del xj is wij. Alright, so now if we write out the whole vector del L by del x, then in the first row j is going to be 1. So j's not, sorry, not. So this is going to be the sum over I del L by del yi wi, but now j is not, and then j is equal to 1, so it's going to be the sum of I del L by del yi wi 1, and then I think you can see the pattern, we just increment this, dot dot dot. So if I expand out this sum, then you can see, so j is equal to 0, j is equal to 1. So let me just write the i's across the top. I is equal to 0. So I'll write the term in this sum when I is equal to 0. So del L by del y 0 times w 0. And when I is equal to 1, then the next term is going to be del L by del yi, so I is 1, so 1 times wi 1 0 plus, and you can see the pattern, del L by del y 2 w 2 0 dot dot dot, and then here j is 1, so del L by del y I, so 0 w I j, so I is 0 and j is 1. So as you can see, this index is incremented by 1. So if we just carry on the pattern by del y 1 w 1 plus del L by del y 2 w 2 1, so on, and then I'll just do one more row to make it obvious. J is equal to 2, so del L by del y 0 w 0 2 plus del L by del y 1 w 1 2 plus del L by del y 2 w 2 2, and so on. So you can see the pattern there. Now then, as you can see, this is just, so, well, I'll write it out. So it's w 0 0 w 1 0 w 2 0 and so on, w 0 1 w 1 1 w 2 1 and so on, w 0 2 w 1 2 w 2 2 and so on, multiplied by del L by del y 0 del L by del y 1 and so on. Because as you can see, so if I take this times this, get this, plus this times this, plus this times this, and so on, and then the next row multiplied by this, So yeah. But this is just doubly transpose, because if you look here, as we go along a row, we increment the first index, but in our original definition for W, we increment the second index, and vice versa. So that means that it's doubly transpose times, and then this, as we know, is just del L by del Y. So del L by del X is that. And then lastly, if we do the bias, so del L by del B, which index? BI. No, I've got the equal sign. So del L by del BI is just del L by del YI times del YI by del BI. And this all just stays in one dimension, so there's no need for the multivariate chain rule. We don't need to sum over anything. So we know that del yi by del bi, if we scroll up, is just 1. So that's del L by del yi, well, times 1. So if we write out del L by del B, it's just going to be I is equal to 0 here. So del L by del y 0, I is equal to 1, del L by del y 1, and so on. And then this is obviously just del L by del y. So in total, what we've got is del L by del W is equal to, if we scroll up, del L by del Y times X transpose. X transpose. And then del L by del X is just doubly transpose del L by del Y. And then del L by del B is just del L by del Y. And yeah, there's the back propagation done for the linear layer. So thank you for watching.